particle is projected from a point O with speed u at an angle of elevation alpha above the horizontal and moves freely under gravity. When the particle is moved a horizontal distance x, its height above O is y. We're asked to show that y equals x tan alpha minus gx squared over 2u squared cos squared alpha. We start by splitting the velocity u into its horizontal component, u cos alpha, and vertical component, u sin alpha. Considering the horizontal motion, x equals ut cos alpha. So t equals x over u cos alpha. Considering the vertical motion, we use s equals ut plus a half at squared. So the displacement y equals the initial vertical velocity, u sin alpha times t. Then a half a equals minus a half g times t squared. We substitute t equals x over u cos alpha, and we get y equals x tan alpha minus gx squared over 2u squared cos squared alpha, which is what we've been asked to show. Let's look at the second part of the question. Here a girl throws a ball from a point A at the top of a cliff. The point A is 8 meters above the horizontal beach, and the ball is projected with a velocity of 7 meters per second at an angle of elevation of 45 degrees. When the ball is 1 meter above the beach, its vertical displacement will be minus 7, and we let x equal the horizontal displacement. We're going to use the formula that we derived in the first part of the question to help us with the second part. We know the angle alpha is 45 degrees, so we can look at this small triangle to see that the tan of alpha is going to be 1, the cos of alpha is going to be 1 over root 2, so that 2 cos squared alpha equals 1, and we're told that u equals 7. We substitute this into the formula that we derived earlier to get minus 7 equals x minus 9.8x squared over 49. We rearrange this to give us a quadratic in x. We can solve with the formula, and we get the only positive solution being x equal to 8.92. So the horizontal displacement will be 8.92 meters. We're told that a boy is standing on the beach at the point B, vertically below A. He runs in a straight line with speed v, leaving 0.4 seconds after the ball is thrown. He catches the ball when it is 1 meter above the beach. So, let's work out the time it takes for the ball to travel from A to the point where it is caught. That will be the displacement, 8.92, divided by the horizontal velocity, which is 7 cos 45. This equals 1.802 seconds. The boy will take 0.4 seconds less than this to travel that same distance. So the velocity of the boy must be the distance travelled, 8.92, divided by 1.402, which gives us a speed for the boy of 6.36 meters per second.